Securities which are backed by residential mortgages are called residential mortgage-backed securities. In other words, the securitized assets in this case would be residential mortgages. In the United States, there are three sectors associated with residential mortgage-backed securities. Those three sectors are shown right here. Number one, those guaranteed by a federal agency such as Ginnie Mae, whose securities are backed by the full faith and credit of the US government. Category 2, which is quite similar, is those securities which are guaranteed by either of the two GSEs. This stands for government-sponsored entities, and the two GSEs in the US are Fannie Mae and Freddie Mac. So these are government sponsored, but they are not actually the government. So what we can say here is that they have the implicit backing of the government. 1 and 2 are collectively often called agency mortgage-backed securities. And since they have either the explicit or the implicit backing of the government, credit risk is not an issue with these particular securities. And then category 3 is those issued by private entities that are not guaranteed by a federal agency or a GSE. These are non-agency securities, and here credit risk is an issue. Over the next few slides, we will talk about mortgage pass-through securities, collateralized mortgage obligations, and non-agency residential mortgage-backed securities. Let's start with the simplest category, which is mortgage pass-through securities. A mortgage pass-through security is created when one or more holders of mortgages form a pool of mortgages and sell shares or participation certificates in the pool. Cash flow characteristics of mortgage-backed securities. This is fairly straightforward. As we've discussed before, homeowners make payments, and the payments that come in from homeowners consist of interest, scheduled repayments, and prepayments. So these payments are passed through to holders of the mortgage-backed securities. But there is a certain fee in between. Let's say that on average, the rate paid by homeowners is 8%. Then this entity in the middle is obviously going to charge a fee. So this is called the service fee because there is a cost associated with getting the money and sending out notices to homeowners in case they are late and so on. So there is a certain fee. Let's say that fee is approximately 0.5%, and there might be other service fees. Collectively, let's say that the overall fee is 0.6%. The pass-through rate, or the rate that comes through to the holders of the mortgage-backed securities then, is 8% minus 0.6%, which is 7.4%. That is the pass-through rate. Weighted average coupon. The various mortgage loans that become part of this pool might not all have the same coupon rate. The weighted average of the coupon rates for all the securities in this particular pool is called the weighted average coupon. Similarly, each of these loans or mortgage loans might not have the same maturity. The weighted average maturity of these loans is what is referred to as WAM, or weighted average maturity. Over the next few slides, we'll talk about these terms: measures of prepayment rate, cash flow construction, weighted average life, contraction risk, and extension risk. But what I'll do here is just give a summary of the main points. Measures of prepayment rate. I talked earlier about the fact that homeowners will make payments, and sometimes homeowners can make prepayments. When we buy a mortgage-backed security, so now here I'm referring to us as investors, we make a certain assumption about the prepayment rate. And there are actually ways of measuring prepayment rates, and that's what we'll talk about on the next slide. Based on our assumption about the prepayment rate, there will be a cash flow construction. So obviously, if prepayment rates are high, that means there will be more cash flow initially and less cash flow later. Also, the ratio of interest to scheduled payments to repayments will vary based on assumptions about the prepayment rate. The weighted average life is also impacted by the prepayment rate. To take one extreme scenario, if we have a pool of mortgages where all the mortgages are 30-year mortgages and no prepayments are made, then the life of the mortgage-backed securities is going to be 30 years. But it's clearly unrealistic to assume that there are no prepayments. We might make certain assumptions about prepayments based on which we say that the expected life or the weighted average life is 20 years. It is not necessary that the actual life turns out to be 20 years. There is a risk that prepayments are faster than what we anticipated, in which case we face contraction risk. It is also possible that prepayments are slower than we might initially have anticipated, and that leads to extension risk. The single month mortality, or SMM, measures prepayments in a month. Let's consider a simple example. This is the formula for calculating SMM. It's the prepayment for a given month divided by the amount that is available to be prepaid. So what is that amount that is available to be prepaid? It is the beginning mortgage balance for the month minus the scheduled principal repayment for the month. Say that the beginning mortgage balance for the month is 103,000 and the scheduled principal repayment is 3,000. This means that the amount available to be paid off is 100,000. Let's say that the expected prepayment for the month is 2,000. Then the SMM is going to be 2 over 100 or 0.02. Notice that the SMM is a monthly number. It's an indication of what percentage of the amount that is available to be prepaid will be prepaid in a particular month. The annualized version of SMM is called conditional prepayment rate, or CPR. And just to understand what CPR means, let's consider another example. A CPR of 6% means that approximately 6% of the outstanding mortgage balance at the beginning of the year is expected to be prepaid by the end of the year. Keep in mind that if we are evaluating a particular mortgage-backed security with several years remaining, then simply knowing the SMM for 1 month or the CPR for 1 year is not enough. We need to have an assumption about the prepayment rate for the remaining life of the mortgage-backed security. And that is done through something called the PSA benchmark, or more specifically, the 100 PSA benchmark. We don't need to get into too much detail at this stage, but just remember the following point. The 100 PSA benchmark is expressed as a monthly series of CPRs. In other words, if we say that our assumption is that prepayments will happen at the rate of 100 PSA, then we are making a statement about the CPR over the remaining life of the security. Exactly what those assumptions are, or exactly what the prepayment rates are outside the scope of this discussion. What I will do is make an appendix available where this is explained in more detail, but strictly speaking, from an exam perspective and given the learning objectives, you don't need to know the exact rates. You just need to know that 100 PSA is referring to a certain series of prepayment rates. Another important point is that if we say that the PSA assumption is greater than 100 PSA, so if we say that our assumption is that prepayment will be based on 150 PSA, this simply means that the prepayments will be faster than based on 100 PSA. And I'll make this even more concrete. Let's say that a particular mortgage-backed security has 100 PSA assumption and another mortgage-backed security has 150 PSA assumption. We are saying that the prepayments here will be faster, so the life of this security is going to be shorter. Similarly, if we make an assumption that the PSA is less than 100, so another security has an 80 PSA assumption, then the life of this security will be longer than the 100 PSA security because prepayments are slower. Now let's look at cash flow construction, and this is based on Exhibit 2 in the curriculum. The monthly cash flow to bondholders for a $800 million mortgage pass-through security with a weighted average coupon of 6%, a weighted average maturity of 357 months, a 5.5% pass-through rate, and assuming a 165 PSA. So what we are being told here is that there is this pool of mortgage-backed securities and we are making assumptions, or we are given information related to the weighted average coupon rate, the maturity, the pass-through rate. This is the rate that the mortgage-backed security holders will receive. We are also making an assumption about the prepayment rate. Now, what is the actual cash flow? If we consider month 1, then the numbers in bold are given and we need to be able to calculate these other numbers. Month 1, we are given the fact that the mortgage balance is 800 million. We are given the SMM of 0.00111 and we'll be using this to calculate the prepayment amount. The mortgage payment is given. Net interest payment, this is what we need to calculate. And how do we calculate this? We are given the 5.5% pass-through rate. This is annualized, but our discussion here is on a monthly basis. So we take this number, divide by 12 and multiply by the beginning balance. That will give us the net interest payment. The scheduled principal repayment, this number is calculated by taking the mortgage payment from here and subtracting the gross interest payment. The gross interest payment for month 1 is equal to this rate of 6%, which is the overall coupon rate coming based on the pool of securities or pool of securitized assets. So 6%, which is the annualized number, 0.06 in decimal, divided by 12 to convert this to a monthly number, multiplied by 800 million, which is the initial balance. This gives us 4 million. The mortgage payment is 4.8 million minus 4 million. That gives us approximately 0.8 million, or 810,844 to be more precise. This prepayment number is calculated using the SMM that is given. Recall, SMM is a measure of the prepayment, and if this SMM is given, we plug in the SMM over here, 0.00111. This is equal to the prepayment for the month, which we need to calculate, divided by this difference. So in other words, the prepayment for the month is simply SMM multiplied by this expression. The beginning mortgage balance for the month is right here, so that's what we put here, 800 million minus the scheduled principal repayment for the month, which is calculated right here. So we take this difference, multiply by 0.0011, and approximately we will get this number. There might be a rounding error, but this is roughly what we get. The total principal payment then is equal to this number, which is the prepayment plus the scheduled principal repayment. The final item here is the cash flow, which is equal to the net interest payment plus the total principal repayment. Based on the way we've come up with this first row, you can come up with the second row. The beginning of month balance, this is based on the previous minus the total amount of principal repayment. Think of this as given, this as given, and you have to come up with the rest. Weighted average life, or WAL, gives investors an indication of how long investors can expect to hold the mortgage-backed security before it is paid off. I have already alluded to this. We can make different PSA assumptions, and at times we might be told that on this particular security the PSA assumption is, let's say, 100. Now, given a certain PSA assumption, there will be an expected life. We don't have to calculate this number, we just might be given the fact that with 100 PSA the life is this. But what you need to be able to do is say that if the actual PSA turns out to be higher, say the PSA turns out to be 125, which means that prepayments are happening at a faster rate, then obviously the average life is going to come down. In fact, as we move to the right and we make higher and higher PSA assumptions, the average life decreases. What we are talking about here is contraction risk. Contraction risk is the risk that when interest rates decline, the security will have a shorter maturity than was anticipated at the time of purchase, because homeowners refinance at now available lower interest rates. What is happening here is not only are we defining contraction risk, but we are also explaining why this might happen. Consider the homeowners. When they took out the loan, there was a certain interest rate. Let's say that at that time the interest rates were 8%. So their mortgage payments are based on an 8% rate. 2 years later, interest rates come down to 6%. What will homeowners do? Answer is they will refinance. In other words, they will take out new loans at this lower rate and use the proceeds to pay off the original mortgages or the original loans. And the mortgage-backed securities, which were based on those original loans, will then be paid off faster. In other words, when interest rates go down, then prepayment rates go up and the average life of mortgage-backed securities comes down. Next point is extension risk. This is the risk that when interest rates rise, fewer prepayments will occur because homeowners are reluctant to give up the benefits of a contractual interest rate that now looks low. This is the opposite of contraction risk, where let's say that initially we made a 165 PSA assumption. After that, if interest rates go up, then prepayment rates will slow down and the life of the security is going to go up. And investors in mortgage-backed securities don't like this either, because when interest rates go up, investors would like their money back so that the money can be invested at higher rates. But obviously, homeowners are not going to make prepayments, and the life of the mortgage backed security is going to be extended. That risk is called extension risk. What type of prepayment risk would an investor be exposed to at prepayment rates faster than 165 PSA, and what would be the consequence for the investor? Notice that if the prepayment rate is faster than 165, then the average life goes down, so the risk faced here is contraction risk. On the other hand, if the prepayment rates slow down, then the risk would be extension risk. Next, let's look at the consequences for the investor. Prepayment rates are faster than expected. If this is the case, that implies that interest rates are probably lower than expected. When interest rates are lower, then homeowners refinance and the prepayments go up. From an investor perspective, he is getting money back faster than he expected, and that money is coming back when interest rates are low. Clearly, the investor will not be too happy about this because he now has to invest money at rates that are lower than the rate he was receiving with the mortgage-backed security. Another point I want to make here is that both contraction risk and extension risk are considered types of prepayment risk. Many students relate prepayment risk only to contraction risk, but I'm emphasizing here that even extension risk is a type of prepayment risk. You can think of this in the following way. When investors buy a mortgage-backed security, they make an assumption about the prepayment rate. In this case, let's say the assumption is a PSA of 165. Prepayment risk is the risk that the actual prepayments will be different from 165. And as we've said several times, but I'm repeating here, if the actual prepayments end up being faster, then the investor faces contraction risk. If the actual prepayments end up being slower, then that creates extension risk. We've talked about extension and contraction risk. Now let's also look at environmental, social, and governance risk for residential mortgage-backed securities. In recent times, rating agencies have started incorporating ESG factors in their assessment of residential mortgage-backed securities. For example, the rating process for a new securitization now includes the potential loss of mortgage principal due to natural disasters. And also, several residential mortgage-backed securities backed by prime mortgages were downgraded because of a potential decline in interest income due to the adverse impact of the COVID-19 pandemic. So the point here is that environmental and social factors are now also impacting the valuation of residential mortgage-backed securities.